Nice. Okay. Hey guys, myself and Matt here are back with another walkthrough. Just fireside chat about preferred node operations. What does that mean? How you can take advantage of it, especially if you're a user of an LST protocol, an LRT protocol. What does that look like in terms of opening new restaking markets? So this is a conversation that will intersect many things. It will intersect liquid staking, restaking markets, slashable security, all these good things. Um, so we want to really talk about, so if we go into it, in summary, we want to talk about this preference-based stake delegations. So how, as an owner of staked ETH, can you express preference for a node operator that it's going to work in a restaked market for a restaking application?
What is a preference? Like, how do you define a preference, if I may?
Yeah, there's multiple approaches to do this. There you can do anything from issuing a statement that is kind of like a sandbox for what somebody that receives a preference can do. Anything to from that to signaling. So you can signal and back with in this case with capital an entity that is reliable, trustworthy, all these other things, as an entity that's going to work for, work with your capital to grow that, to access more yield in the long run. That's what you want to do. You want to put your capital to work, your staked ETH.
Okay, so if I get this right, a preference, like I'm just going to use a very wide known concept is like the intent and things like so it's not an intent because intent
Okay.
is like you just give one time and then someone actually fulfill that, right? It's like
Yeah,
more
that's a
of like
partial transaction. Yeah.
it's like a prompt, like you give. But this is like what are you saying? The preference is I you're giving an assigned right to a third party. In
Mm.
return, they will do it as based on what your preferred outcome should be.
Mm.
And
Yeah.
that preferred outcome is like, in this case, is like, hey, I'm gonna give you the stake, I'm gonna give you my ETH, and you stake it with the Ethereum, and then you also do XYZ for me. And it's like, yeah, we will do it, but you don't know they will do it or not. And
Correct.
there's a lot of
Correct.
if and if. So the preference is more of like, very generic statements that you can encode. So the reason that you don't know would what if they will not, you know, the path dependency diversion happens instead like,
Oh.
oh, they're not doing it. How do you enforce your preference? Because you already given the preference and you give the capital. So now you need to,
Mm.
as you said, the signaling, you need to prove you're indeed the owner, you're indeed the ultimate, the owner or the principal agent, right? So the agencies fall back to you. You could enforce your preference at any given point of time if you can prove you're indeed the owner that who have expressed that preference. In this case, is like when you give to a staking pool, you will get a deposit token that is called an LST or an LRT in this case, right? So a degree backward before it become a stake and you have an LSTs. And there are protocols that actually do this kind of preference for, you will only get the asset, and then once you have an asset at stake, you get a encoder preferences like stakeouts that has like you can actually do the preferences as much as you want because it's not like backward, it's like much forward, like
Mm.
restake
Yeah,
preferences.
yeah, yeah.
But you can
Yeah, I mean,
also
this.
have an LRT and LSTs. So the preferences could also be layered upon. I don't want to get into too much into the
Yeah,
generality of the preference, but end of the day, if you want to enforce a preference, you need to prove you're indeed the person who has a right to override a preference that has been, encoded in the first place.
yeah, absolutely, absolutely. So different protocols, you know, you can do that via protocols or directly yourself. Different protocols will spin up on this. Like a non restaking example in the DeFi world is to give your, rather than creating a liquidity position directly in Uniswap, you may give your capital to a protocol that will do that on behalf of you, and you express your preference on how the ranges should be managed. You know,
Right.
there's range-based management, right? So it's no different here. You're saying you're expressing a preference on how the capital should be used. You know, which node operators that you want your capital to be used by, and which networks they need to be working in, right?
This is actually a good point that you mentioned about the range you want to set. You're indeed in the same pool, but you can actually give your LPs through a range manager in a Uniswap v3 and say that you define the rules, and then this actually going to get me better returns on my LPs. But there's a
Mm.
small caveat here. In a normal DeFi is kind of like you can rage quit if they don't do that. But
Yeah,
that's
yeah.
like a very limited preference that you're still giving. Like it's a one-time statement. But in the delegation, it's kind of voting analogy. Like, of course, the preference actually came from the statement delegation from the beginning. We can look into that later. But the thing it is like, how do you make in a representative governance? You choose an election. You choose a leader. And to choosing
Mm.
a leader, there should be an election, a delegate, right? So you choose a delegate. And the cost of choosing someone to do something for you is always more expensive than doing that once or two. Like the delegate will vote and on behalf of you, they will exercise the voting power that's accumulated, all kind of stuff. So in the earlier example that you said, like the LPs is being given to a manager, a range manager, and if they are not performing, he can rage quit. But the preference is a bit more than that. You can still, let's assume that you're given a an amount, let's say $1 million, right, into a co-processor, right, like some sort of a smart contract, strategy says that I will do XYZ, right? And I will do XYZ if the price goes up, and I'll always follow this market. I will follow the emission rates of ETH. I will follow the better extended markets. But you think they're not up for the job, or you think you're better to give this to someone else and they can manage this in a better way. But you still need to keep the original service provider that you have engaged for doing partial work, or they can still do whatever they want to, but you still have the control to optimize it. And that's the beauty. The
Right.
thing it is, you can still enjoy, the range is not performing well. It's not preferred outcome that you're expecting. They're doing everything they can, but it's not good. So, and in a very naive way to think about it is like, you and me having some money in a bank account, right? And I put like 100K and you put like 150K. Both of them are protected by whatever the FDIC and all this kind of stuff. And a year later, the bank have a lot of services they offer. Like they have some trading, they have some ISA, they have some, stock markets, investments, mutual funds, but that's just the banks are providing. But you think like, I'm not sure about this, but I can opt into all this kind of stuff. And this like if you're part of this, and we will manage your money, and then you have your wealth manager from the bank, and yada yada yada. But your relationship starts that you're using the banks for the first preference is manage your assets there, right, in a balance sheet. Now,
Right.
you want to give an extended right to a different asset manager. Your wealth is still sitting in a Bank of America. And I have appointed someone who can manage it behalf of me, and he's going to give better traders and things like that. I know the risk, but I appointed someone, or I myself is going to trade with my money. And a year later, my 100K has become 200K, and your 150K only made like 25,
Right.
175. But we
Yeah,
both
yeah.
use the same bank as in the base, right? So this is like the preference is like how can you optimize your existing capital that you staked with multiple layered service providers.
Right,
By not rage quitting, you can still enjoy the benefits, but you can still enforce your preferential rights. And you can get closer to your preferred outcome. And everybody's preference is different.
True. Very, very true.
Yeah, so everybody's winning. Like the service provider here, they get their money, they're trying to optimize it, but the users can still add additional layers. But in that time, those earnings goes to them directly. Where I said that both if I do the trading, those comes to me. Maybe I'm earning with my cap, but you still manage the capital. I still authenticate my account balance with the service provider and say that the traders know that, yeah, okay, indeed, he has a bank account. It's been in our system. It's plugged in. We can get the money whenever it needed. I can give you some leverage here and there. I can give you more services and all this kind of stuff.
Nice.
Okay, cool. We're getting like a little bit outward. Cool.
Yeah, no, but it's good. So in summary, right, we're just saying that we have that PNO has the ability to offer the restaking applications ETH/able security for outside networks. So that's the benefit. You have the staked ETH that is being made available for outside networks, and those outside networks are willing to pay some utilization fee for that capital that's been given to preferred node operators. So a user is not directly allocating that to any given network. They're allocating it to operators. And if the operators are not performing as expected, that is an adjustment that will require an adjustment of the earnings, basically. So something you mentioned a few seconds ago, Matt, was about authentication. And I think it's a really important point, is how do you authenticate balances in the system so that services can be offered to that stake. And so we have a visualization here of so if we go lower level, so what is happening at the chain level on Ethereum, and we think about what is happening here when staked ETH is being registered. So you have an Ethereum deposit contract that will register BLS credentials on the consensus layer with a minimum of 1 ETH deposit. So in most cases, the validators are being registered and activated with a 32 ETH balance, but you only need 1 ETH. So that is just like to record credentials. Then consensus layer, once it receives the minimum required induction balance, will go through the process of activating that validator, and we will add the consensus layer will add that validator to the append-only list of the so you have a validator list. And that validator will exist in the consensus layer state. Consensus layer will track, will then activate that validator to do work for the application consensus layer. There is voluntary exit here in that process, and consensus layer is managing all of that within its boundaries. So authentication on the Ethereum virtual machine is about making that stake available for use inside of the execution layer. So what you have here is a single direction of communication at the start. When the validator is registered on the consensus layer and ETH is attached to that BLS balance, that is a one-way communication from the deposit contract into the consensus layer, which will then vote on the incoming deposit, add the validator to the validator list, and then that validator can perform activities based on that staked ETH. But that is not replicated back to the Ethereum execution layer. So that is now taken care of by a credibly neutral stack, proof of neutrality, has a proposer registry, which is a single sign-on for all of the validators on the consensus layer. So it's basically a lookup table for validators with a status. And the validators in that list are either active or removed from time to time when they become inactive on the consensus layer. So any updates on the consensus layer will reflect on the proposer registry. So
would you say that this is more or less like, an open banking, where if your banking credentials, when the financial data is accessible by third parties, and that third-party protocols can use it to deliver better financial services for the customer, that we all benefit from it. And there's a lot of there's a lot of benefits like challenger banks and things like that. But what the key part is, like, you get this kind of aggregated results and you have authenticated data, and you can pin it back to a user who is who and what is what. In this case, it's like the validator registry, right? That gives this
yeah,
whole thing on the EVM.
yeah. So open banking is a great innovation. It's a really good point. It's it's this the ability to sync all of all of your banking accounts into a single location. Like you said, for a variety of reasons, fintech challenger banks are able to leverage that information to provide services for people to manage their money more easily. There's a whole host of other benefits to that. So the proposer registry is like that open API, right? So other smart contracts can actually interact with validators. So we're talking about the programmability of validators here, and basically anyone able to hook into the proposer registry in order to understand what what is the aggregate amount of staked ETH that can be remarketed outside, and which validators it comes from. You can pull that. You can do all kinds of things on top of this, but this is the open API layer. This that for looking up Ethereum validators. No, I think it's a really good point though. So validator authentication forms this basis. So validator authentication in the proposer registry, which we're saying is analogous to the open banking layer, that forms the basis of what is required for the node type PNO operations to work. So every validator that is authenticated in the proposer registry increases the delegatable balance, right? So you have, when you're expressing your preferences, you're doing that through a delegation to a preferred node operator. So that's what we're calling the PNO. Now, you can only express your preferences on the basis of balances that have been authenticated from the consensus layer. So this allows you to build applications without. So the authentication part, is in part based on the, we have the beacon block root in the EVM. We have all that nice magic, EIP 4788. We have all that stuff there, and that ensures that the data can be made available in a smart contract without having to use proofs all the time. So once it's authenticated, then you get a balance, an aggregate balance from all of the validators that have been authenticated, and you can use that balance elsewhere in as simple as using an ERC20 balance, right? And we've seen all kinds of applications on top of the ERC20 standard, So,
but there's a difference. This is authenticated and mapped, and it's kept in real time and on EVM, regardless of what is the history. So you always get this kind of, even you take in EIP 478, it just gives a state for it. But this is like more granular level, like each and every validator, entire life cycle has been encoded into a registry, and you will get that the latest tip, latest balance. Like, how do you know that the latest tip of the chain, right? So and it just get appending. So the history is appended, history is aggregated and appended, all the time. Effective balance is there. There are certain rules. If you want to add it to a registry, there's certain health reasons. Like, and if you, I think I'm just falling back to the open banking. If you're like someone who's like, some sort of constraints and things like you still have that, but you will not be able to get some certain services. So this gives more programmability, more rich service that you could provide to the stakers and those representing those stake tokens. And that's more important. And 1 degree backward, you will get into that for sure. I know that. But just want to mention it, just when you have this kind of completely ETH stake authenticator, you can remap into other kind of assets that you minted for those things before or afterwards.
Well, yeah. So if you're holding a token, absolutely, this is a really important point. If you're holding a token that represents a validator stake on consensus layer somewhere, so we're talking LSTs, LRTs, where the underlying ETH has gone to the Ethereum deposit contract and created validators, whether it's created in a pool. So you hold a token that ultimately represents a stake in a validator somewhere on the consensus layer. And therefore, you hold the right to authenticate the validators associated with that token into the proposer registry.
You can have isolated slashing within a staking pool because you can just, curate the set of the validators and just give the LRT tokens to deposit and just extend those things, and then you can only slash them.
Right.
You can
Right.
have partial delegations, you can have partial slashing or isolated slashing and things like that. You can have your own pools, and because you have all the ledger has been replicated here.
Yeah. Well, let's talk about that. Let's talk about the origination of a slashing, you know? So that's really important to understand.
Maybe better that you explain what's the key difference between an LST and LRT. There's not much. There's only one or two. What is the difference between
Yeah.
LST and LRT?
Yeah, so an LST takes ETH and uses it for a single purpose, and that is to create validators on the Ethereum consensus layer. And often those validators are pooled, and the yield is socialized amongst all the token holders. You get a midnight airdrop, and that kind of thing. So the capital has only a single use case there. An LRT aims to make the ETH that is staked available for other restaking markets. But as of yet, we have not seen. As of yet, I would say a lot of LRTs are mainly behaving like LSTs at the moment.
Only the
Really,
difference would be that you give a preference with a commitment from in the protocol says that we would definitely get you additional yield.
yes, but it's not specified how and where, and ultimately the LRT token holders don't have a seat at the table sometimes here to express that preference of where it should be
Right.
used.
Like for example, in a rocket pool, an RETH holder, a node operator could indeed do restaking as of today.
Yeah,
If the
true.
rocket pool DAO is not going to enforce a slashing from their side that they do run and then they can get slashed, right? But it's in a similar way that I'm just taking the rocket pool as an example. And Lido, if the Lido allows slashing can be injected and then given approval, boom, they have the LRT. They just become restaking friendly. So
Wait, so this is like a protocol, like not a protocol upgrade, but it's a kind of you can an LST can upgrade its status pretty easily with the just a proposal, a DAO proposal.
yeah, so any protocol that has a withdrawal custody, all right, like you have an access to that ETH could be given to someone else and to disperse the rest of the amount. All you need to remap the validators who did that. So this is why I said like node operators of the Rocket Pool, because they have all the Rocket Pool node operators registered. They have the users running that. And then if they've been a preferred node operators and things like that, if they're doing a restaking node operator, they could indeed like anyone could actually participate in the restaking.
Right.
RETH is a different story, but now you could, if there's a slashing is incoming, Rocket Pool can just forfeit the RE that belongs to the node operator, right? Or the RPL and things. But at the moment, they will get slashed because of this single utility that you mentioned. Because so it's more of a DAO decision that do you want to have one single yield or you want to have multiple yield?
Multiple tiers, yeah.
Yeah. So the LRT, LSTs, from an architecture perspective, not very different. You just need to approve a slashing window. And if you can get, that's why we're enabling this, like anyone can upgrade an LST to LRT, restaking feature. I'm sorry saying NLRTs, but LSTs could actually capture the restaking market.
Right, and
Simply,
boost their yields, right? So break
yeah,
past that 3% barrier,
yes, yeah. And you can enable the window and you can remap who has participated and how much to participate. This is the preferences that we're coming back into. And but we're looking in this presentation, we might be looking specifically in the Eigen, because Eigen is one of the restaking market enabler where there's a lot of LST protocols docking into the Eigen, and Eigen is doing that kind of slashing window for them.
So yeah, so they're basically saying yes, we will. They're basically saying by starting out as an LRT token, we have ETH staked on the Ethereum consensus layer with an approval for ETH-based slashing of for any offenses that are they're known up front. The list of like the normally it is very well defined in, for example, a proof of stake system, what actions will lead to the reduction of a balance. And normally it's not the entire balance. We've not seen any Ethereum validator lose its entire balance yet, right? So most of the time, if there is an issue like an offline penalty is being applied to a validator, they will you have this like leak concept, and an LRT is saying that the ETH is slashable under certain conditions, whatever that is agreed with the markets that they opt into. And so this is no different, right, for an LST to say, okay, well, if an approval is issued or any protocol says they'll give additional slashing approvals, then that will open up different restaking markets, and it's all on chain, all verifiable. The flow of the capital here. So we're basically giving any protocol a restaking factory here.
But things get actually very murky if you have an exogenous committee or someone who can slash capital holders ETH, right, without having any kind of skin in the game.
Balances restriction. Well, yeah. So what is the origination of a slashing, right? It's a delegation here. So a protocol can decide what is its appetite for risk here by controlling the amount of delegations it issues. It might have 10,000 ETH worth of delegations, but 500 is given at the start.
Yeah.
Which will define the slashing, the existing risks.
Yes.
Go
ahead. I'm not.
Yeah, no, that makes sense. Cool. So, what? So yeah, we in this we can talk about eigen-based examples here. So this is along the lines of what we were talking about already, how you define an LRT token, how they're minted, etc. So we're looking at Eigenlayer as a restaking market enabler with a demand for custody of assets. So that the ETH being withdrawn from the consensus layer is slashed on the way out for any slashable offenses that occurred whilst participating in the various markets that are available. But that is not going to be the only restaking market out there, and the question comes is how this can be opened up to to other restaking markets like PNO for the additional yield. So, it's maximizing the capital efficiency here, right? And putting the money to work in as many places as possible. So again, with an approval-based approach, further markets can be opened, and protocols are in control of the delegations here. With the ability of the LRT token holders, for example, to be able to express preferences in the PNO-based markets. So typically what is happening with an Eigen-based smart contract system is you have capital that is staked through EigenPods. Sorry, just one second. Now, there is a restriction on the Eigenlayer. So Eigen have an EigenPod manager, which is the factory contract for all of the EigenPods. Each EigenPod creates its withdrawal credentials. So it's a withdrawal credential factory.
What is an EigenPod?
Well, yeah, I'd say it's a withdrawal credential factory for allocating ETH, and it is a
smart contract address. That's what you're saying.
Yeah, correct. Yeah.
Because you cannot have an EOA address as a withdrawal credential and then do a bunch of approvals on top of it, right?
Right, correct. Yeah, absolutely. So it offers programmability. It's, and yeah, so that opens it up to restaking markets, which is useful. There are some conditions within the Eigen protocol that the pods have to inform the main protocol contract, the pod manager factory. So it has to inform it about balance changes, there's balance syncing. So the pod manager just tracks for every Eigen pod the total ETH shares that are associated with the pod that have been restaked. Interestingly, the partial withdrawals are not restakeable at this point.
So what is a share? What do you mean by share?
Yeah,
I do not hear any kind of share mechanism in staking with this.
Yeah, it's kind of it's something internal to Eigen, and Eigen is tracking. So for a validator that's created through an EigenPod, and the withdrawal credentials are assigned to that EigenPod address, the pod manager, the factory that created the pod, will represent those that restaked ETH as it has a share tracking mechanism. So
when you say share, is that a share of a pooled, or like I'm just trying to understand the share mechanism here a little bit better.
Yeah.
I don't know about it, but just trying to get to the normal definitions of a share. It's like you have 100 shares has been issued, and out of that you have 20 shares. Is that so, or is it just arbitrary numbers say that you have X amount of shares of what? Like of what? What is a share? Is that?
It's a pseudo ETH balance. It's supposed to represent the ETH restaked in an EigenPod. So it's not really there's no share relative to the total amount of ETH staked in the protocol or anything like that. I know exactly what you mean, but no, this is more of a representation of an ETH balance. So it's not really strictly classed as a share in the traditional thinking.
Yeah, the shares, then you have this kind of solvency rules comes in, right, in the form of verification. It's like...
Yeah, exactly. So it's more like your delegation capacity as a pseudo ETH balance.
As a pseudo ETH balance. So
yeah.
Okay, fine. That's great. So related to what? So you have a pseudo balance of someone. So you have my account balance in one bank and two bank, and you can actually have my whole, wealth balance, but you can actually have like a single account balance in a one bank, or you can have a single account balance in an account category, like checking account, savings account, blah, blah, blah. Like, what is that pseudo account balance tethered to, related to? Is that a credential?
It's tethered to an EigenPod.
Oh, okay. So you have a smart contract address generated by a factory, and you have a
Yep.
pseudo ETH balance that you can query a pseudo ETH balance to that smart contract address at any given
Yeah,
point.
yeah, yeah,
Okay,
yeah.
okay.
And
Now I get it. I get it.
uh, but there is a limitation in that. So Eigen will say that you cannot deploy more than one pod for an Ethereum wallet. So every EigenPod has a pod owner, and in an LRT protocol, this is a smart contract. So LRT smart contracts are EigenPod owners, but an LRT protocol, for various reasons, may want to deploy more than one EigenPod to, for customer fund tracking, whatever the reason is. So they have to use and get around restrictions in Eigenlayer by having like proxy contracts to EigenPods. So an LRT protocol can own multiple EigenPods via sub-child contracts. So they have to deploy. The pod owner has to deploy like a little child owner, 1, 2, 3, 4, and then each child owner can deploy its own pod, and they're tracked by the EigenPod manager. So it gets sometimes a bit tricky to track the balances here.
It's like you have 100 safe, nodes safe addresses being deployed from the
Yeah,
same EOA, and
yeah,
then
yeah.
each nodes safe approve is connected to, like, each nodes safe has some ETH balance. In this case, nodes safe actually have ETH.
Yeah,
But
yeah.
let's assume that every nodes safe has some sort of a pseudo balance attached to it,
Right,
and
right.
you have this kind of a hierarchical mapping. But you could actually tether it into one address, and you can actually have multiple. So
True,
that's
like a
how.
shadow owners, yeah, the shadow
Right,
owners.
right, right.
Mm.
That's a good analogy. Yeah, I get it. Oh, cool. Right.
Yeah. So ultimately, the LRT protocol that is the smart contract owner of these pods, that is the one that is managing the funds, but
Yeah.
they cannot directly access the funds of the EigenPods. Um, there is delegation requirements and requirements for any capital coming out of an EigenPod to go via a delayed withdrawal router. And that is enforced for all the partial withdrawals. So all of the rewards earned by a validator are not being restaked. They have to be withdrawn. There is no inside of the EigenPod, there is no attribution of shares for partial withdrawals. So the only thing getting restaked is the base 32 ETH,
Is
which
the
means the
withdrawal
security is not
router
increasing.
is same for every EigenPod, or is the withdrawal router is specific to each and every EigenPod?
No, it's for every pod deployed at the Eigen protocol layer. So it's an ETH pool for ETH that is coming out of the system, the Eigen system. It's
So
for regardless of
all money actually goes into this withdrawal router, single
yeah
withdrawal router, or
yeah.
all
That's
of.
where the sausage is coming out. So the ETH is going into the consensus layer via however many pods are deployed. There's n number of pods deployed. So ETH goes via the pod as a proxy into the Ethereum deposit contract, which goes into the consensus layer. But on the way out, it's pooled, and a delay of 7 days is enforced. Presumably, and I'm only making a presumption because we don't work for Eigen, so is that will be used for slashing later to put everything in one place.
How does the sweeps actually can go there? It's going to be extremely hard to track the sweep amount if you pull it between credentials.
Yeah, so you basically the consensus layer data is stripped off and basically a queue of withdrawals is created. So it is just saying so at the EigenPod level,
And
once
does
the user
the sweep
requests.
amount actually goes there, or just only the exit amount, or all the amount, whatever the ETH is coming out, will goes
Oh, so
through the
any ETH from the consensus layer will go there. So if the validator has completely terminated operations on consensus layer, everything will go into that. But the partial withdrawals will go there as well. So, but that's moved from the EigenPod into the delayed withdrawal router. So if you get a partial sweep of 0.05 ETH, the EigenPod will say, okay, delayed withdrawal router, Matt is due 0.05 ETH in X amount of days time. So.
Who pays for all this gas?
The LRT protocol, actually. LRT protocols are spinning up the pods in the first place, and I've seen some protocols like they'll pre-prepare the pods, so they'll try and when the gas is low, they'll try and spin up like 100 empty pods or something like that. Then later on they'll get utilized. ETH will flow through. It's interesting because you can actually bypass the pods and send the ETH directly to the Ethereum deposit contract. There is the pod is just a proxy to the Ethereum deposit contract. It's not recording any data saying, like, there's no record saying, oh, I processed the deposit of BLS key, blah blah blah. So it is merely all the pod is saying is thank you for the ETH. I will send it to the deposit contract. It's just forwarding, and yeah. So then after that, one needs to there's an operation called verify withdrawal credentials. So you invoke Beacon Oracle. So there is an oracle that you ask for the generation of proofs on Beacon state roots. So they have their own. It's not a chain level proof. It is it's called a beacon oracle. Not chain level. Yeah, that will verify.
It's an injected proof.
Yeah, correct. Yeah. On some withdrawal, yeah, some consensus state. Yeah.
So how do you make use of this thing, which is very much walled garden?
Like in terms of creating new
PNO.
markets.
Yeah, the PNO. Yeah.
So, simply your LRT protocol would give an approval to a contract that can add liens, and
you still need to get an authenticated ETH balance. You need to track it.
Yeah, right.
You cannot just
right. Well,
out of thin air.
Yeah,
it's like that goes against
no.
every rules in the smart contracts in crypto.
Yeah, no, definitely. Well, yeah, delegations is on the basis of a delegatable balance. So it's kind of in a similar way you can create a validator if you do a deposit on the Ethereum execution side, you can create a validator on the consensus layer side. If you authenticate a balance, if you authenticate a consensus layer validator, then it creates on the execution layer a delegatable balance, and that delegatable balance can actually be used. That's like a capacity. So the more validators are authenticated, the more delegations that are possible, which means more earning potential, right? So if an LRT protocol has 100,000 ETH, but only 2,000, only 3,200 ETH is authenticated, that is its delegatable balance and will cap its earnings, right? Compared to if all of the validators in an LRT protocol are authenticated. So that is this side here, right? So, but approvals can be issued independently. Approval says that I want to opt into the PNO, markets, and my LRT users will be able to delegate once there is delegatable balance, right? So that is what is authenticated here in the proposer registry, sorry.
What I'm reading,
delegation.
What I'm reading from you is just like there's no special thing here. It just you have X amount of ERC20 tokens minted that has some connection to a withdrawal credential or a set of withdrawal credential that has could have Y amount of ETH at stake in consensus layer, because it could different amounts. Now, unless that you have an authenticated balance that map back into that withdrawal credentials and the validator balances, you cannot have a proof of solvency for the ERC20 tokens that has been minted
Yeah,
on
correct.
Ethereum execution layer. There are a lot of rules, like, there's a lot of inflated minting can happen. Like that's not, you said that there's delay on EigenPod deployment, there's delay on approvals coming in, some of them is not. So you really cannot rely on any of the data on the manager, on the shares, or the pseudo balance. You must authenticate the validator, and which closely resembles to any other withdrawal credential as per the consensus layer rule. If you can authenticate, you can actually allow them to give an approval. So you really want to have a replicated ledger for the validator and their relationship to a withdrawal credential, or the smart contract address in this case, because a withdrawal credential could also be EOA. So in this case, we just filtering it out for smart contracts and then asking them to give an approval for giving the ETH for slide. So these are two different things. Like in order to perform the delegation could be performed natively by the protocol if they can authenticate how much their balance sheet is with the validators.
Yeah.
When they authenticate the balance sheet, then the subsequent LRT or LST tokens can also enforce the delegations. That's really cool. Because now you have dual preferences, right? The rights is being given back to the ultimate beneficial owner. Now, how the slashing could be done, because the LST tokens could deposit in a vanilla vault and say that, oh, you slash me, but they don't really have to do that. In a delegation, they only need to delegate, and it could be slashed from the underlying ETH when it comes out. That's more beneficial for, you can actually expand your restaking market to multiple, level. The slashing at the first case could go. That's where the restaking is all about, right? The restaking protocol should approve the slashing, correct?
Yes, correct.
Otherwise, it's just an ERC slashing. You don't want that. You can delegate with the ERC and force a delegation through the ERC representation token, but the slashing must be approved by the protocol that with the withdrawal credential owner. Is that correct?
Yeah, that's correct. That's correct. And that approval will basically check for any debts when ETH has been claimed. So there could be thousands of pods, and you're claiming ETH. Whenever the ETH has been claimed, partial, full, whatever, the debts are checked, and that is paid, and then the rest stays with the protocol, just like this is what we're saying here. So there's an ETH claim. You may have approved from LRT, K2. There's all these kind of different protocol integrations.
The slashing rules before, like,
yes,
before
correct.
the delegation made, like some of the slashing need the whole delegated amount could be given as an approval. That doesn't mean that they can take all the money. The slashing has been approved, comes in. Some of them doesn't really need all the slashing, but you can really control. The levers are like through the delegation. You can undelegate anytime, right?
Yep. Exactly. That's really important. There's always an opt-out. Always.
Yes.
Yeah, so that's really important.
Cool. Thank you.
So we can actually look at a case study. Taking, for example, Ether.fi. So they have EETH, or they have wrapped EETH as well, which is existing on some L2s. So this really does scale to L2s if you have an LRT balance on a layer 2, for example, wrapped EETH. Now you can do your delegations there. With the as long as there is a authenticated validator as on the L1, and you can just issue the delegations on the L2 and make your earnings from there as well. So that's not a problem here.
Well, if you authenticate with a PON registry, you can actually read that from any L2 because it's a registry contract.
Yes, correct. Simple read operation. Yeah.
And then you only need to give a slashing approval on the domain specific, right? So if you give that, still your slashing is as I said, the delegation is the one that is controlling where you're going to give it. So your LSTs can flow to any L2s or any rollups. And then, if you just add it to an OP stack kernel, like, you give an OP stack and then you can approval, you can actually get that ETH from the L1. And that's basically like a delayed claim, but you can submit a claim there. You can also delegate. The only delegation can happen at the protocol level or by the ultimate beneficial owner of the stake, which is the LST LRT token holders. If I'm the LST LRT token holder and I have like 10,000 ETH, and it's like, hey, protocol, I want to be restaked my 10,000 ETH. Nobody can stop me. It's my ETH.
No.
Yeah. Whatever the slashing
you
comes from my delegation, just take it from me, no problem. But I'm going to earn from that. That's my isolated delegation. And the protocol say that, oh, this delegation came from this users. We're gonna, will not give you that ETH. Fine. But now you can get it.
Yeah, agreed. Totally.
How does this
agreed.
work? Tell me how the Ether.fi works. This is pretty cool.
Yeah, yeah, like I said, there's some restrictions on the Eigen protocol side for how many pods you can deploy by a single address. So Ether.fi have been creative with they have this concept of a node manager. So a node manager and node smart contracts. A node smart contract owns an EigenPod. But the node is managed by the node manager. So this node manager smart contract, it owns all the pods. Can own and manage all the pods. But from an Eigen perspective, the EigenPods will individually point to individual node contracts, and then be co-managed there from the top. So top level, who can like claim the ETH, who can partially or fully, who can exit the validators, manage the pod, all that stuff. That is this guy here, the node manager smart contracts. And any ETH, so any consensus layer ETH coming into the pods will get pulled via this node managed contract, which will so like we said, the LRT protocol is paying for all the gas here. It's paying for all the gas to prove the withdrawals, verify the withdrawal credentials, withdraw the ETH. Right, that gets moved when the ETH is being claimed, like partial ETH and the full fully unstaked ETH. That will get moved to the Eigenlayer delayed withdrawal credentials, and then later the LRT protocol will come back and pay for some additional gas to bring that into their protocol. So in the case of Ether.fi, it's going into their liquidity pool. So the liquidity pool is there for receiving ETH from the creation of the ETH token. So it basically has a faucet when there's inbound money from outside. So not on the Eigen side, when there's money from users, it goes into the liquidity pool and ETH is minted there. And then when the ETH is burned, the liquidity pool is paying out withdrawal NFT holders. And that liquidity pool is topped up by the ETH coming from the consensus layer, which goes into the pods, EigenPods that are managed by Ether.fi via the node manager smart contracts, which owns all the different filed accounts. And they have their own, there's about 37,000, I think, validators on the Ether.fi side. Yeah, the idea would be for the either the protocol to authenticate those validators, or the LRT holders will be able to do that because it is, there is a mapping from pod to, Ether.fi node manager smart contracts. So that's completely doable. So yeah, so we spoke, a fair amount about the, how things are working under the hood. This is just more technical details on that. We have references to the implementations on Etherscan that, where these things can be sort of cross, verified against. And like we said, that the pod manager is really just a withdrawal credential factory, which then will pool all the ETH coming out of those pods into a delayed withdrawal router in the end. So what if, how do I basically, so we spoke about expressing preferences, and various examples are given, like you said, or, one person might put 100,000 in a bank account, another person might put 150, but just because they put more money in the bank account doesn't mean they're going to earn more, right? So, you know, your expectations are not being reached, right? So, you've parked your capital, you don't feel like, it's working for you. What is the way to boost this, right? And if you are parking your ETH in I don't know, we'll call it LRT token, and it's they're not restaking or participating in all of the markets that they could be participating in, you know what do I do? How, can I create a withdrawal NFT? Can I burn the token? How do I get my ETH back? And then where do I go next? And it's all kind of weird, like all these different hoops that I have to jump through in order to actually restake my ETH. Is there a simpler way of doing this? Is the question really. So that we can get restaked capital in maybe some other form. How do we see this?
You're talking about a very aggregation, like there's a fragmentation of LRTs, and then you want to have like this could be analogous to checking account switching in open banking, or you could have like the mint kind of like service providers, like fintech service providers. That's who provide you kind of a aggregated, and they give you some sort of a score to you, and then say like, okay, you have this, these are in our network. We can give you some specific access to some products, and we can aggregate all your balances. So you may have some tokens in EE, some tokens in RESI, some tokens in FE, some tokens in XE, some tokens in SATR. I don't know, a lot of tokens. If you can give me the mix and LP share, we would give you a combined exposure to a restaking market where other node operators can compete to get your delegations. So now you're literally like going for the optimized earnings from the restaking without taking much headaches on how to manage your underlying LRTs. Does that make sense? You muted. Cool. So,
That
right.
definitely makes sense. Definitely makes sense.
And that could be for, meanwhile, this LRTs are pooled, you could actually allow this could be used for additional lending markets and things like that, or all of this value that is capturing, not only from the restaking, from the lending, for other kind of stuff, it's will be prorated back towards you. So you have, let's say LRTs like 2 LRTs and 3 LRTs, or 3 the whatever you eat, your convenience yield is getting more and more over the period of time if you just use this kind of NDS concept. Okay, makes sense.
So what is pretty cool here is for the protocols that are participating in the PNO markets is that the ability to express preferences with the capital being held. So you may, LRT tokens may change hands, and the new recipient of the tokens may be very happy with the the current configuration of delegations to PNOs, but equally they may feel the performance is not as good. So they're kind of like a board, like a board of a company, and the board might say, okay, well, things are going well, the company is being well run, but maybe things can be updated.
So you can always update your preferences if it's not if the preferred outcome is not being met, you can enforce your preferences at any given point of time. That's what you're saying. And you can still share it. You can still share the delegations, but you can enforce your preferences as you are at any given point of time. That's the beauty. You don't really have to rage quit, but you can still have like your own voice, and your voice will be heard. Yeah, that's cool. I mean, the cost of shared governance of shared LPs and things like, you always have this kind of a dilution. You always have the kind of like, what is you never get a preferred outcome. 100, not even close to 70%. It's like, yeah, but what if I can optimize myself, right? That's the world. Capitalism is also all about that, right? You born it, but you could become anyone you want. The freedom. So this is like, okay, you are here, you have some base allocation, but just like you could optimize it. And that's a statement. Doesn't mean that you have given to a service provider that you have to, you cannot do anything. You're not out of option. You always have an opportunity to optimize, to enforce your preferences. You can always grow. But I have a question on the last slide then.
Right. This one or
No, the slide before that you mentioned NDS. So
yeah.
in this thing is have a large pool. If a DEX or an intent provider just basically going to borrow it, like you have this kind of if you want to have an order book, an RFQ should be preferred, not operative, quote unquote, and you delegate to that, and they could have their LPs to get the delegations, their tokens, and you can have all this kind of a new kind of the intent-based networks can be deployed and use this kind of one large pool of tokens, and you get not only the restaking market, restaking security, but also the LP, and then you pay for them. So you have the LPs, you can give the LPs, you can borrow it from there, but now your LP holders are also securing your operations.
Yeah.
These are
Makes
very
sense.
lightweight operations, like in RFQs and things like. You don't really have to go to an intermediary. You can just directly do that operations here, and then you pay them two ways. Like your LP returns is based on your volume and trading and things like that,
Okay.
but you're restaking it in just like in some sort of a meter, right? In your points, or like not the points, for God's sake, this like a real token accrual so that you can redeem it later on. So that's cool, because we see a lot of hybrid model of like intent order books to get to L2s, and you can have like a share deposits. You can have this deposit could be used for multiple L2s, and you can do the bridges. You can have bridging liquidity from this, and and the bridges basically restaked by the same LPs, and then you have the liquidity there. They get both. They get the revenue. They also get being an LP, but they also get the restaking revenue from that.
Pretty nice.
I just thought about it when you said like it just because of the preferential delegation, you enforce it, right? The underlying tokens can enforce the restaking, and which means that the protocol who are actually allowing the deposits and accepting the deposit in LSTs can also enjoy the restakeable security from there. And they indeed return that benefit back to the user who are part of the community.
Nice. It's more user aligned. It's that's much better. Much better.
Yeah.
So there's software available to make this more streamlined and available to validators for running additional software for the new restaking markets, but also to authenticate the balances if needs be. That's the PNO activation and stuff. It's a layer. It's called MEV Plus, and it's a layer that allows programmability of validators. And I think it will become quite an important part of the ecosystem, really. Here.
This is base route, right?
Sorry.
This is base route. Like you can authenticate yourself.
Right. But if you're part of a protocol, liquid, protocol, then your token holders can also do the the authentication as well.
So all the LRT protocols can simply prove that, authenticate their balances on the pure purpose registry, or you can, if you're just solo staker, just use a MEV Plus. If you could also, if you're an LRT protocol, you can assign someone to do that job for you, authentication just from a node operator side. But this is the base route, like permissionless, but just like you can
Solo
also
stakers
do that.
is good one to mention. Solo stakers are not normally participating in the restaking markets at this point. You know, like if you're a DApp node user, how can you participate in restaking? You know,
PNO module is available on DApp node.
right? Exactly. Yeah, exactly. So you know, this case for the long tail user, and does not leave anyone excluded because there's not if the solo stakers are excluded from restaking and all these future earning opportunities, it's not good for the network because they may be inclined to unstake their validator. So that doesn't help the strength of the network. But yeah, this was I think this was a good discussion. And I
The
think that there's
PNOs
going
are
to
available in Holiski, not in mainnet, but you can test it out.
yeah, correct.
The authentication can happen much more faster, right? The PN proposed registry.
Correct. Yeah.
So there might be some of the validators will actually get like, you can have a designated authenticator for that, just onboarding. Just like your bank is connecting with an open banking, all the customers get benefit from that. Just like your LRTs can authenticate the balance, the validators, and all the LRT token holders can benefit from additional earning potential for their, tokens and will be accepted regardless on any chains and L2s that is getting bridged, you can actually enforce it.
Yeah, exactly. That's correct.
Nice. All right. Thank you.
Awesome.
All right.
Yeah, see you guys on the next walkthrough.